Okay, hello everyone. This is Applied Domain-Driven Design Blueprints for Jakarta EE. My name is Reza. I'm a Jakarta EE ambassador. I'm one of the folks that helped launch that group. I also happen to be an author, blogger, and speaker. I've been for a little while. On the screen, you'll see my email address and also my Twitter handle. In my day job, I'm principal program manager at Java at Microsoft. So let's talk a little bit about what this talk is about. So basically, this talk is about a project called Cargo Tracker. It's a Nicholas Foundation project. It's part of the broader Jakarta EE project portfolio. So I started this project actually quite some time ago. This project was started back in the Java EE 6, or rather the Java EE 7 timeframe at Oracle. It was then part of the overall Java EE portfolio of projects. So what is this project about? Well, there's a couple of different parts of the project, as I talked about in the title, if you will, to some extent, alluded to in the title to some extent. So one aspect of this is domain-driven design, or DDD. Another aspect of it is Java EE, or Jakarta EE now. So going back a few years, actually back in the mid-90s or so, hopefully some of you have heard of the Java Pet Store, or the so-called J2EE blueprints. So basically, the J2E blueprints conceptualize the idea of design patterns. So design patterns used to be in the Gang of Four patterns book, and largely were geared towards Java SC projects rather than server-side projects. So what the J2E blueprints did back then is take the idea of design patterns and architectures and actually apply them to the server side. And they were actually hugely popular at that point in time. And in fact, many of those design patterns that were introduced back then, we are still using today. If you've heard of DTOs or DAOs, which we won't be talking about here, we will be talking about a little bit about DTOs. All of those things actually came out of that idea. Facades, which is also in use in the project even today. All of those design patterns came out of the J2E blueprints. But the problem, of course, that the J2E blueprints had their own problems, and it's not per se the problems of the J2E blueprints themselves, but rather the underlying technology. And actually, one of the biggest problem with that was entity beans. So what entity beans provided you was essentially which we now call anemic domain models. So a domain model where you model data but not behavior. And as a result, you actually could not model the basic heart of object orientation very, very well. So it's a funny thing, Java actually is an object-oriented language. That's one of the key reasons why you would want to use Java. And because of the way entity beans were structured, and because of the way the J2E blueprints were aligned, you really actually couldn't do proper object-oriented development using those technologies. So as a result, what happened was there was a rise of in terms of the shortcomings of the technology, there was a rise of things like Spring and Hibernate. And on the architecture side, there was a rise of this concept called domain-driven design that basically emphasizes that idea, okay, that let's go back to the roots of what object-oriented development really is about, which is about modeling your system, your domain, right? So whatever software you are writing, that software ought to look like the real world thing that you are writing the software about. So if you're writing a software about accountants, well, the objects in that domain should behave and look and be named a lot like real world accounting. Or same thing with retail or any other particular domain. So the nice thing about Java EE or Jakarta EE, as opposed to old school J2EE, is that this programming model is very much POJO based and very much enables DDD philosophy extremely well, because it's a lighter weight programming model. So actually, this is the reason I launched Cargo Tracker back in the Java EE 7 timeframe, is to demonstrate that, in fact, Jakarta EE or Java EE can embrace and actually be a great example for how to model DDD-based systems. So that's what this talk is really about. It's a bit about explaining DDD. Even after so many years, DDD is not a new architecture anymore. It's well proven. Even after so many years, a lot of people actually don't quite understand DDD and have never really had much of an introduction to it. So we're going to talk a little bit about DDD today, but more importantly, we're going to talk about how Cargo Tracker as a project actually shows you how you can model DDD architecture using Jakarta EE as a programming model. All right, so let's get started. So I actually, what I've tried to do is not reinvent the wheel in terms of any kind of architecture design patterns. DDD, as I said, is well established. So it should be possible to take all of the DD artifacts and simply explain them in an easy way. So that's basically what I've done. If you go onto the Cargo Tracker website, there's also an explanation, a simple, lightweight explanation of domain-driven design as well. But we don't try to reinvent the wheel, and we even try to reuse the artifacts that are out there. So, for example, the artifacts that you're seeing on screen now, that is an explanation of the basic building blocks of DDD and how they relate to each other. And this is not a diagram that I invented or made up. This is actually from a DDD book itself, and it happens to be a pretty good diagram. So we'll talk about what these basic building blocks are. You can think of them, these things are actually as each of them, they're unique design patterns, but they're all interrelated in some ways. They're interrelated in the so-called domain model. So we'll start with entities. This is probably by far the most important thing that you're going to talk about in terms of DDD. So an entity is a noun or a thing in your system. So again, you're modeling real world systems. That's what DDD is about. It's domain driven design. So basically designing all of your objects in your system to model the domain that you are implementing. Okay, so in the real world, all the things all around us and the thing that we're modeling are things, they're nouns, right? So whatever you're going to be working with, these are nouns. If you're designing a transport system, you will have packages and transport plans and roads and cars and trucks and trains and planes and so on, right? So these are all nouns. And in the real world, you can actually uniquely identify these things as well. Each thing has a way of saying, okay, this is this particular thing. A car will have a license plate number. A person will have a social security name. A house will have an address. A phone will have a number, so on. So, and in case of identities, it is a distinctly identifiable object in the system, okay, that has an ID. So that is what an entity really means. We'll see all of these things in action in terms of the Cargo Tracker application in a moment. Okay. So value objects are very closely related to entities, and it is a new, it is the next domain concept that you really need to understand. So value objects are also things in your domain. So they're also nouns in your domain. But unlike entities, they are not uniquely identifiable. Okay, so one good example of this is, let's say you have an employee entity. The employee will have an ID, but under the employee may have an address. So while you can map an address as an entity, there's no reason to do that because the address is so tied to that particular employee, and there's no reason that you need to access the address in a separate way. So you could model the address as an object that has a containing relationship with the employee, and that is what a value object is. Okay, so it's a value object is also a thing, but it doesn't have its own unique identity, and we'll see examples of this in the application as well. Mostly value objects are useful in terms of proper modeling and encapsulation of objects. Okay, so in real life, most things are made up of other things, but not everything that something is made out of needs to be uniquely identified. Moving on to the next concept and next design pattern are aggregates. Okay, so in real life, what happens is a domain is actually consisting of many different entities. Okay, so in a typical non-trivial domain, you will have upwards of 30 or 40, maybe even a few hundred of these entities. And what winds up happening is you observe that there's clusters of entities, so things that are more closely inter-designed together. And what aggregates gives you is a way of modularizing those objects together. So recognizing that there's closer relationship with certain entities and value objects, and then there are others. All right. So an aggregate is a couple of things that, as we'll see in a moment, they're both a grouping of entities, as well as it can also apply to a special type of entity called an aggregate entity. So when you have these groupings of entities, you will find out that there's one single entity that sort of controls the other. In that cluster of entities, that entity is the most important one. All right, so that is what is called an aggregate entity, and that grouping of entities and value objects and other artifacts like repositories, those actually represent an aggregate. And this is best actually taken a look at when you take a look at the example code. When I show you, you'll understand a bit better of what aggregates actually mean and why they are valuable in creating more maintainable and more modular systems. The next design pattern we'll talk about are repositories. Repositories are simply a kind of facade, if you will. Right? They're a facade at the data access layer, and what they do is that they create a separation between your business logic, your domain logic, if you will, your entities and value objects, and the rest of your objects that model the real world, and the data access code. So some code that just its only purpose is to access and retrieve these entities from the database. Because at the end of the day, in all systems, you can't have the systems in memory. They need to reside in some kind of permanent storage, whether that's SQL or NoSQL or what have you. And the repositories are the facade between these two worlds. And basically they look like they look a lot like DAOs, or data access objects, if you're familiar with those. But there is some differences. A repository is usually tied to an entity. Okay, so they are a little bit more coarse-grained than the DAOs. The DAOs tend to be a little bit more fine-grained. So they look like you're accessing a record as opposed to accessing an aggregate in particular. Usually, a repository will be tied to an aggregate, so it will retrieve larger coarser grained parts of your domain as opposed to very small bits of data. Okay. Factories are another important concept. So this is sort of comes from the Gang of Four design patterns. There's definitely an analog to that. So in many cases, creating an entity will be simply a matter of instantiating the new operator and calling some setters, and then you have your entity. But it's not always as simple as that. In some cases, your entity creation may be a lot more complicated. Okay, so when you have those type of complicated relationships between and aggregates, you sometimes need an abstraction on its own to just create the object, and that is what a factory comes in. And we'll see an example of both things. We'll see an example of just instantiating the new operator and having that be it. And we'll also see some examples of when you need factory objects in your domain model also. So finally, I'll move into services, and services is a bit more complicated. In a way, this terminology came about before SOA, right, or concurrent with SOA. So there's a little bit of and especially now RESTful services or microservices, there's a little bit of a nomenclature overload. So these are not services in the sense that it is SOA or in the microservices sense. Okay, these are actually domain services. So domain services are a unique concept in domain-driven design. Here's the issue. In most of the cases, the domain you are modeling is going to be consisting of nouns. Okay, so those nouns will have data Those objects will have data, but they will also have behavior model with them. But there are some specialized cases where the behavior is so important that you need to model it as a top level object. So for every single domain, there's an example of these things. So in transportation, for example, routing would be a pretty important one, right? So routing is actually its own, you'll have a routing service, for example. For example, insurance, and a very important verb is things like underwriting, determining risk for a given individual and how much that you can insure them for. So underwriting service would probably be an important domain service in that world. So whatever your domain, you'll find that there are some of these cases where verbs, actions are so important that they are actually primary components in your domain role as a peer of the objects as well. Okay. So one thing that I forgot to mention, there's no reason to hold back Q&A. As we go along, you can ask questions throughout. Just post them in the Q&A, please, or in the chat. I'll try to take a look at the chat. I'll take intermittent breaks here and there. And try to see what kind of questions you have. But don't hold back questions in the end. There's no real reason to do that. Just, if you have a question, just post it right then and there, and I will stop here every little bit and make sure to take questions from you. Okay, so those are the primary building blocks. Next, we'll talk about layers or separating concerns. But before I do that, I will actually give maybe a few seconds. If you have some questions so far, you can post them, and let me try to see if I can check the chat real quick.
Well, Reza, I will forward for you the questions.
Okay, great. That'll be very helpful. Thank you very much. So I take it there's no questions so far, right?
There are some questions, and I will forward now for you.
Okay, can you kindly do that? Yeah, tell me what the questions are, and we'll answer them right away.
Yeah, I write to chat directly, and I will also tell the question. How can we move from anemic model, transactional service layer, stateless AGB plus entity to domain-driven design? Where should we start our transactions? Should it be in the services you just mentioned? I can reply the question if you want.
So can this person hear me?
I think so.
Okay, so if this person can hear me, so how do you move from an anemic domain model to a rich domain model with DDD? Well, you do it like everything else. There are some specific techniques that I'll talk about in a second, but basically you would want to do this in an incremental fashion. So one of the things DDD is applicable to very well is legacy systems. There's many different ways, many different techniques prescribed in DDD of moving from essentially legacy systems and modernizing your architecture. The way you would want to accomplish this is probably by dividing your application into bounded contexts. So one of the bounded contexts is going to be your old system, so the system you're coming from, and you will want to create a new bounded context or a new component or new module of your application that is modeled in DDD instead. And in some cases, you would want to keep those parts of the bounded context actually subdivided, and we'll talk about that in a moment as well. There's various techniques of dividing up the modules in your system and having some sense of separation between them, so you don't get cross pollination or cross contamination of these bounded contexts. And what you would want to do is gradually refactor each of these things. So in your refactoring of your system, when you're applying DDD, you'll basically be rethinking your entire domain model, or at least that part of the domain model, using DDD as opposed to using an anemic domain as the anemic domain layer. Where do you start your transactions? That's a good question. It's definitely not in the domain services. The domain services, again, these are not going to be, in most cases, the domain services will be doing something. but these are essentially will be mostly models of business logic. So ideally, you won't actually even need transactions when you are when you're performing a domain action. This will be simply a matter of mutating your object state or your system state without necessarily needing to call any external infrastructure. So that's not the right place for transactions in most cases. Where you would want to apply transactions is actually when you need isolation levels and when you have a database involved. And in most cases, that's actually going to be either in the interface layer or in the application layer. Okay, you'll see this in a moment. The application layer is where you have these so-called transaction scripts. Okay, in other words, the modeling of higher level use cases in your system. So that's a very logical point where you would want to use transactions, because that's where you will be interacting with the database, okay, for the most part. Same thing with interfaces. In some cases, you may have interface layer concerns that is directly accessing the repository. And in that case, you're sort of forced to use a transaction. So you can apply a transaction at the domain layer facades as well, okay, or simply the domain layer objects, for example, a view adapter. That's where you would apply your transactions. Any other questions?
Yeah, there is two more questions. One is, can you explain value object again, please?
Value object.
Yeah,
Value
the
object.
value object.
I think the best thing is to just take a look. Wait a little bit until I show you the examples. It is just a way. It is just another noun in your system. But the difference is, whereas entities have their own IDs, right? In other words, if you really want to think about this just in terms of relational database modeling or even JPA, they are basically your at entity objects, right? That is what a entity is. A value object, on the other hand, in terms of JPA in particular, it's easy to understand. It's anything that is an embeddable. Okay, so whatever an embeddable object is, it's typically going to be a value object, but not always. Sometimes it's useful to model value objects as entities also. But basically, the differentiator between them is they're both nouns, right? They both look like entities in JPA, but one has a ID, right? So at ID annotation versus another one that does not. And typically, that's going to be an embeddable. And any other questions?
Yeah, the last question is, where do sagas fit in these all building blocks? The
I'm
saga
sorry?
pattern. It's
Saga.
mentioned about the saga. Yeah, where do
Okay.
sagas fit in these all building blocks?
Okay, so sagas do not have anything to do with DDD per se. All right, so CQRS, you can think of it as an add-on to DDD. So saga patterns really belong more to CQRS, the world of things, and in particular probably have more to do with event sourcing. So I would say it's a bit out of scope for this, right? So sagas are a way of modeling long-term processes that look transactional in nature. But this is too far out, right? Compared to where we're talking about when we're talking about the basics of DDD. For example, there is no example of a CQRS or event sourcing or saga in Cargo Tracker, right? So that's a separate talk, unfortunately. Most people will be lost if I begin to explain sagas when the talk is about the basics of DDD. Okay, any other questions? But we can take it offline, so you can email me offline, and we can chat about sagas there.
Yeah, currently there are no questions, and three of questions are okay. Thank you.
Okay, so let's keep moving forward. So next, we'll be talking about separation of concerns. So believe me, I've seen a lot of this is a bit of an argument in the DDD community whether or not layering is part of DDD or not. In my opinion, it is. And in fact, if you look at the original DDD book, it does spend time talking about layers. So the reason layers are important is to organize your code in a sensible fashion. If you don't have layers, what you have is you have a set of domain objects, typically entities and some repositories maybe, and also some value objects and services, the artifacts that we talked about before. But what tends to happen is all kinds of concerns is intermixed together. Okay, so you have interface level code intermixed with application layer code, intermixed with domain layer code. So it actually defeats the purpose again of trying to do DDD in the first place. So the whole reason you want to do DDD is so that you have some part of your system that models the real world and looks like the real world, the real world domain that you're trying to model. And if in your modeling of those objects you have infrastructure level concerns like UI and database and transactions and scheduling and messaging, well, guess what? Your domain model no longer will look like the real world. Okay, because those things are not real world artifacts; they are artifacts of our implementation of the real world. Okay, so the way you handle this problem is by having by separating your code out into also layers, and typically there's only a set of well-defined layers, right? We typically understand in a given server-side system what the layers would be like. So these are the typical layers in an application that you would have. And also notice that layering is not mandatory. Okay, so if you really take a close look at the diagram I'm showing you and you look at the arrows, it's not necessarily the case that the interface layer will always go through the application layer to access the domain. Okay, so you can skip layers if you needed to. The primary value of layers, again, is to segmentation of those concerns. It's not about enforcing particular rigid hierarchy or anything else like that. It's about encapsulating concerns. Okay, so let's talk about these common layers that are applicable in DDD-based systems next. So we'll start with the application layer. Rather, the interface layer. The interface layer is basically a simple way of looking at it is all of your UI concerns. But it's not actually limited to that as well. For example, if you're modeling just services and all you're really writing is RESTful web services, for example, those RESTful web services portion of it, the portion that maps an HTTP requests and creates something that is sensible in your domain, that object, in terms of Jakarta EE, for example, your JAX-RS resource, that is part of your interface layer. Same thing for if you're writing a JSF application or MVC application, all of your controllers and DTOs, all of those belong in the interface layer. Okay, those are all in interface level concerns. And in fact, many of the classical J2E design patterns have survived in the interface layer. So things like MVC, DAO, not DAO, pardon me, MVC, facades, DTOs, all of those actually belong in the interface layer in one way or the other, not rather than the other layers. The application layer is really what we were talking about before, like where do you apply transactions? It will typically be in the application layer. And the application layer's job is to model the higher level use cases of your application rather than the domain model itself. Okay, so you can think of this as those, we talked about those verbs. So these are system level verbs. All right, so adding a user, allocating insurance, buying a car, selling a car, buying a house. Okay, these are selling a house, mortgaging a house. These are the higher level use cases. When you're talking to your business domain experts, okay, you'll be talking about in terms of these use cases. So these are the use cases that are modeled in the application tier, and we'll talk about that in a second when we take a look at the actual example code of the application. All right, so let's move on to the domain layer. The domain layer is all of those things that we talked about before: entities, value objects, and so on. Those all belong in the domain layer. Infrastructure. Infrastructure, unfortunately, when you're writing about systems, this is going to be an important part of the equation that you just cannot remove. So these are all of those extraneous things that are cross-cutting concerns for the most part. Transactions is one. Asynchronous thread handling is another. Messaging is another. Logging is another. So these are all infrastructure level concerns. And infrastructure actually is a cross-cutting layer. You want to segment those interfaces into their own objects, but they don't fit in like this containment hierarchy. okay, that typically you can create with interfaces and applications and domains. Instead, infrastructure is applied often in a declarative fashion. In terms of, especially in terms of Java EE, infrastructure is actually expressed through annotations. So when you are placing an annotation on an object, really what you're doing is you're consuming some kind of infrastructure. So infrastructure belongs across all of these tiers and can be applicable everywhere, but they still want to be segmented. You want to try to segment those concerns separately. Logging is actually a very good example, like in our system. So you want to apply logging everywhere, right? But you want logging to be segmented in its own component layer structure and be applicable only when you actually need it. Okay, so let's begin to talk about mapping these DDD objects to Jakarta EE, and this is basically what the application at the heart of it, what it actually does. So you have several types of interfaces. At the interface layer, you will have JSF, you will have Jakarta REST, we talked about already. You can have WebSocket, you can have the Jakarta Batch API. All of these APIs will actually be applied to interface level objects. Similarly, your applications will typically be modeled by EJBs. Okay, so that's where you are going to apply things like security, transactions. You would want to apply them at your use case level. Okay, that is where your transaction script is. It can also be modeled using CDI. Entities is an easy one. Typically, in Jakarta-based EE-based systems, an entity will be a JPA entity. Similarly, value objects, pretty easy one, right? Typically, when you have a value object, you're going to want to model them using JPA embeddables. Infrastructure is most of Jakarta EE, this is where it's going to be applicable. Whether it's persistence level code or messaging level code or REST client or email or what have you, this all has to do with infrastructure. Okay, so these are what all of the technologies that will and more that's applicable to the infrastructure layer. Typically, when you're applying an annotation, all you're really doing is expressing an infrastructure dependency. Repositories will typically be the entity manager level code. Okay, so they'll look very much like your entity manager objects. In fact, in many cases, you can consider not even having a separate repository layer. You may be able to get away with it. Okay, so if you're using, for example, Delta Spike data or Spring data, right, your repositories may be generated for you. Or you may be choosing to use just the entity manager directly. In many cases, you don't need another abstraction. The entity manager is rich enough to function as the repository. Okay, so these are different ways of modeling your repositories. All right, so bounded context, I won't spend too much time about this, but this is where DDD meets microservices or SOA. All right, so basically what this says is that a large enough system, and most large systems are not going to be just a flat structure where everything is under one module. Instead, most real life systems are going to be broken down by modules of some kind. So an insurance-based system will have underwriting, will have point of sale, will have evaluation, will have payments. All right, and these are the different bounded contexts or components or modules of a given system. And in DDD, there's a specific way of handling these things and understanding these things, and also understand that when you have these subsystems will talk to each other. Modules will talk to each other. How do you do that? Is you do that through a context map. And there's many different techniques that you can apply of how do you handle communication boundaries between modules. So there's big polymer or the anti-corruption layer or separate ways or open host or conformist or shared kernel. Okay, so you can take a look at each of these techniques and understand how they map to effectively microservices or modules. All right, so these are a little bit coarser grained, right? So they're more applicable to SOA or coarse grained services than it is necessarily to microservices, but you can apply the same type of concepts in microservices as well. All right, so let's finally move into the example code. I'll stop a little bit and take any questions, but I think the majority of the session today is the remainder of the session, which is actually not much, I'm going to actually just give you a brief demo of the application, introduce the application, introduce the actual project, and then show some of these concepts that we talked about in action. So let me stop now and let me ask if there's any other questions right now. Any questions?
No, there's no another question.
Okay, great. So let's move forward. So here's the application website. So this is everything that we talked about is actually already here. So there's an overview of the project. There's goals of what we're trying to accomplish. There's instructions on how you get started. You can get started with an ID or without an ID. It's your choice. In fact, today, actually, aside from just showing you the quick demo of the application, I'm going to, for the most part, be using the browser without an ID to show you the code. So this is how you get started. The application, by the way, is running on the cloud. So if you click here, okay, here's an instance of the application running on the cloud. Okay, in fact, we can use the either my local version. I'll use my local version. This is localhost port 8080 running the application on my own machine, but you can also go ahead and use it on the cloud if you want. So this is some of the things that we talked about in the background for this project, how Jakarta EE maps to DDD, okay, and also some specifics of the technologies that we have used for this application. So as you can see, we've used Faces, CDI, enterprise beans, persistence, REST, JSON, bean validation. So a good subsection of the Jakarta EE APIs. We've shown you how you apply those particular technologies to in a DDD fashion, okay, in a DDD style. So where you really actually want to go, and where we should go in a second, is the GitHub repository. So this is the GitHub repository for the project. This has some subsection of what's on the website, so all of the getting started instructions. It'll also tell you a little bit about how you explore the application itself, so the different parts of the application, and how you go about exploring the code and exploring the code on the cloud as well. So let's take a quick look at a quick demo of the application. Can't spend too much time here because I do want to show you the example code more than this. So there's several different interfaces. One is a public tracking interface. So we can just enter some information here, and basically it will tell us the current state of our cargo. Okay, so we can see where the cargo is in Helsinki right now. There's an estimated time of arrival. It's expected. Next expected activity is we're going to load this cargo onto a voyage in New York. Okay, this is a little bit of a map showing you what is going on. So there is the destination Helsinki. This is the last known location is New York, and the origin was Hong Kong for this bit of cargo. You can take a look at other cargo here as well. Okay, and this one is not yet received, and it's in Melbourne. Okay, so there's its origin is Hong Kong, and it is destined to go to Melbourne, but it's not received just yet. The other interface here is the administrative interface. Okay, so this is showing you all of the bits of cargo that are currently available. So these are the routed cargo. So if you want to take a look at the details of this, there's origin, destination, and a deadline. These are the different ways that the cargo will go from point A to point B. So this is the itinerary of the cargo. Cargo can be either routed, not routed, or claimed. So this has been MNO 456 has been claimed. Okay, so it's also got a very simple itinerary. We can also take a look at a live map. So this will show you a map of what all of the cargo is and what its current status is. We can actually go ahead and do a booking. So let's go ahead and do that. So let's say we want to go from New York as a source to, let's say, Tokyo. Okay, so let's say we want to do that in, we want it to arrive in July 16th. Okay, so the journey duration is 52 days. I'm going to book the cargo. It shows up as not routed. We need to route the cargo now. So this is our cargo. We can go ahead and route it. And we can see that there's a couple of different ways that we can do this. So we'll pick just one of them. Okay, there's also another part of the system that allows you to enter the tracking information. So you will say, what the cargo is. Okay, so let's do ABC123, where we want to load it. Okay, what the event type is. So there's various different types of events. So let's say we want to load it. And what voyage do you want it on? Let's just randomly pick one. Some time, let's just pick whatever there is, and you can submit it. Okay, and this change will be reflected in the administrative interface. So I just did some kind of action on ABC123. It's probably the wrong action. So most likely this cargo is now misdirected because of what I just did. So let's go ABC123. Okay, it's still not, it's still okay, it seems. So let's see my object processed, it did. Okay, so basically that's the basic things of the application. I don't want to spend too much time on it. Again, you can read the exploring the application section in the documentation, and it'll tell you what the application is about and how you can play with the different parts of the application. So now let's dive into the code real quick. Okay, so we don't have a whole lot of time anymore. So let's go into the source, main, Eclipse. Let's go into the cargo tracker application. I'm going to increase the font size a little bit so you guys can see what's going on. So as you can see, these are the layers: the application layer, the domain layer, the infrastructure layer, and the interfaces. We'll jump into the domain layer first. The domain layer, as you can see, is subdivided into, we talked about aggregates before. These are all the aggregates in our system. So cargo handling, voyage, these are all aggregates. So voyage has things that are related to the voyage, okay, entity and value objects. Cargo is probably one of the most important aggregates, the most important aggregate in our system. So this is the cargo entity. Okay, as you can see, it's modeled with the entity annotation. Cargo has a tracking ID, which is an embeddable object. It has a location, which is an entity. It has a source location. It has a route specification. It has an itinerary. Okay, we saw the itinerary in action in the application. It also has delivery status. All right, so these are all of the things that are in the cargo aggregate. Okay, so for example, routing specification is a value object. All right, so as you can see, it's modeled as an embeddables, and there's a number of important things in here. There's a location, the origin, the destination, and the deadline. Another one is delivery status. Okay, delivery is also yet another embeddable or value objects, very important value objects. It has a number of important information related to where the cargo currently is. So the transport status, the last known location, the current voyage that it's on, whether it's not misdirected, what its current ETA is, what the next expected activity is. So, and what you'll also notice is that this has all of these things have business logic. Okay, it's not just about modeling just data, but also behavior. So let's go take a look at the cargo object, for example. So there is a few getters and setters, but a majority of it is actually has to do with value objects. So specifying new route, assigning cargo to route. Okay, these are not getters and setters. This is actual business logic that is being modeled in the entity. So that's what makes an entity rich and not anemic, right? So that's a example of your value objects and entities. Let's move into your infrastructure. Okay, so a big part, there'll be many different parts of your infrastructure. So have CDI events, logging, messaging, persistence, routing. These are all of the different parts of the infrastructure that I'm applying. Very easy example is JPA repositories. Okay, so for example, this is the repository implementation corresponding to the cargo aggregate. Okay, so here's the finder. Here's the find all method. There's the method to store the actual entire aggregate. Okay, these are all of your repository implementations. Now moving back into, let's take a look at the domain model, let me show you an example of a factory. So there's handling event factory. This is an instance of a factory. So the cargo domain, you can basically more or less get away with just invoking it from the repository. In case of handling events, it's not as easy as that. So you will have components that you will do to create a particular handling event. But in order to create that handling event, you'll actually need to do a number of interactions. You'll need to find a cargo entity, the voyage entity, the location entity, and then construct the handling event in a sensible way. So it's a non-trivial bit of code, and it is all abstracted into this factory. Moving into, let me show you an example of a domain service. Okay, so here's a domain service. In our case, routing is a very important verb. Okay, so when you notice that I booked a cargo, and then I figured out what the different routes are. So that is a very important activity and a verb on its own right. So routing service is a top level concept in our domain. So and the thing that we're going to want to do is fetch routes for a given cargo specification. All right, so there's also all of the interface layer concerns, and this is probably a majority of the code actually is here. This is the most heavy part of the application by far. Okay, so there's a booking interface. We talked about that, right? So all of those administrative functions, those are in the booking interface. We talked about the handling interface. Okay, there's a tracking interface. There's in parts of the handling interface, you'll see that there's a RESTful service, there's a mobile service, there's a file-based service, so on. Let's take a quick look at the application layer and probably stop here because we don't have really that much more time left. So the most important service in the application layer is going to be the booking service. So, and it's going to correspond to those high-level use cases. Okay, so booking a new cargo, requesting possible routes for a cargo, assigning a route to a cargo, changing the destination, which you didn't see in the UI. There's a feature to do that. Changing the deadline. These are all of the high-level use cases in the booking interface. Okay, so this is how your application will actually look like. If you actually took a look at the implementation of it, right? This is the booking service implementation. This is an EJB, right? This is where your transactions are going to be applied. And there's also, these are basically they are not modeling the business objects, but what they are is they're coordinators. Okay, so the actual business logic is let's take a look at this example of requesting possible routes, or rather assigning a route to a cargo. The actual business logic resides here in the cargo domain, but what this application is doing is that it's doing the rest of the work. Okay, so it's interfacing with the repository, calling the actual store object, in this case doing a bit of logging, doing the transaction handling, and perhaps even the security handling as well. So this is the purpose of the application layer, is to model the high-level use cases and and function as a transaction script, so to say. Okay, so I think that is all the time that we have today. Let me take a few more questions if we have any. And then we'll summarize and move on to sharing the resources with you. So any questions?
Yes. What is the difference Jakarta EE than Spring? There are three questions actually.
So Jakarta EE and Spring are both frameworks for developing enterprise applications. So Jakarta EE is an open standard. Spring is a open source project. Okay. Anything else?
Yeah. Can you think that Java must transform to much more functional programming?
Functional programming, there's a place for it. Okay, so if you look at the application, there's many different places where we apply lambdas and streams. This is where we are basically applying functional programming concepts in an otherwise object-oriented system. Object orientation and functional programming, they're not really, they complement each other. Okay, but if you're doing DDD, you're really more in the object-oriented design philosophy mode rather than function-based mode. Function-based systems, those are more useful for transactional systems, systems that don't really have a very rich domain model, and a majority of the system is actually just a model, just a question of modeling behavior more than anything else. But it is complementary. Again, we are using some functional paradigms in the application. We certainly make use of lambdas fairly heavily. Okay. Any other questions?
Yes.
Hello,
Is it
Reza.
wise to model? Can I?
Okay.
Okay. Is it wise to model the domain object as GPA object? Shouldn't we separate the two?
Typically, I would say it's good enough. If you look at your typical JPA entity or embeddable object, they're really nothing much more than an implementation of what you would actually want in the domain model. Okay, and again, you'll see examples of this in the application. There's very little that is very JPA in any of our embeddables or or entities. They really do look very close to what your domain model should look like, and that's intentional. Okay, that is how JPA is actually designed. So all you're really doing is you're designing your domain model, and then you're annotating it with some ORM mapping annotations. So it's unnecessary work. You don't want a unnecessary bloat and unnecessary code in your applications. So in 99.9% of cases, yeah, you do want your domain model just to be implemented, and adding and annotating them with whatever infrastructure that you may need, in this case JPA. Okay, any other questions?
Reza, can you see your chat screen? I just forwarded the question to your chat.
Let me take a look.
Yes. The last one. Yes.
Do you think DDD should be applied to most Jakarta? Do you think there are some patterns where it does not fit in? So here's the truth of it, if you will. I think you should attempt to apply DDD in all systems, even if you don't actually do domain modeling in the way that it is intended. The reason for this is it gives you a common vocabulary of design patterns and common ways of doing things instead of inventing your own wheel, right? So I would say for that reason alone, you should apply DDD everywhere, in all server-side systems. Now, in all reality, DDD can be overkill in some cases, right? And especially if your system doesn't really have a lot of business logic and your domain isn't actually that complicated to map. All right, so in that case you don't actually need that object oriented thinking that much. However, it's still useful to think about those systems in a DDD way anyway, because DDD gives you a lot more even if your domain model is not that rich, right? It gives you that common vocabulary, it gives you the concept of layers, it gives you a way of thinking about your system, right? Whether if you didn't do that, what you wind up happening is just cowboy coding. Like you're inventing your own paradigms, you're inventing your own design models, right? And you're inventing your own design patterns, and it's unnecessary, right? Because in most cases, DDD has already done that for you. So even if you don't, you don't go all the way in terms of really thinking about and understanding DDD paradigms and how do you apply to how do they apply to your domain, it's still useful to just model the system in DDD anyway. Okay, any other questions?
Yes, I just sent you.
I don't see anything else. Where do you put the domain logic, in entities or embeddables? Or so it depends. In 99.9% of cases, you would want to put your business logic in either entities or embeddables. Okay, depending on where they may fit, where it makes sense to model that particular behavior, okay, that particular bit of business logic. In some cases, there's business logic that just doesn't fit in any given entity, or it's business logic that applies to multiple different parts of the aggregates or multiple entities, and that's a use case for having a domain service. Okay, but domain services are rare. I would say probably a good 90% of the time your business logic does belong in an entity or a value object. There's a good 10 or maybe 10 or 15% case where that's not the case, and that's where you would want to introduce the concept of a domain service. Any
Thank
other
you very much.
questions?
No, thank you.
Okay. All right, moving on. Okay, to summarize, DDD is a very, very good architectural blueprint for enterprise Java and Jakarta EE and Java EE applications. Just use them and learn how to use it. It's going to be a very useful tool in your tool chain. Even if you happen to be doing microservices, it's still a very useful way of thinking about systems. Jakarta EE, as you have seen, and hopefully you will see when you explore the application a bit more, is a very natural fit for DDD. Actually, in Jakarta EE, because of the heavy use of annotations and the heavy use of intelligent defaulting, it works very, very well with the way DDD is supposed to be intended, and really allows you to focus on modeling the domain more than worrying about infrastructure. And hopefully, Cargo Tracker is probably one of the best places where you can start understanding how DDD applies to Jakarta EE. So these are some of your resources. Obviously, the Cargo Tracker website itself. I've also put in some resources to learn DDD. So there's a really nice dzone ref card on DDD. It's a 1 or 2 pager, and it gives you a high-level view of what DDD is supposed to be about. There's also a small booklet from InfoQ. Okay, it's not a thick book, it's a small book. It's called Domain-Driven Design Quickly. Okay, it's a good reference book, and it's a good way of learning again. If you want to go all the way, you want to go by Eric Evans's book on DDD. Okay, I don't have it linked here. It is linked from the project documentation, if you want to go find that book. And I've also put together a few resources. If you're new to Jakarta EE, as opposed to new to DDD, you can also learn about Jakarta EE. The best place to do that is the Jakarta EE tutorials, as well as the official Jakarta EE samples. There are sister projects, of Cargo Tracker. So you can definitely follow those links and learn a bit more about Jakarta EE itself, rather than necessarily about how DDD maps to Jakarta EE. So those are all the resources I have for you today. Really appreciate your time. If you have any more questions, I'm easy to find. You can find my website. In my website, there's a contact section, and that has all of my information in it. It's got my Twitter, my email, whatever it is that you want, right? In terms of getting in touch with me, there's also a getting in touch form if you prefer to use that. All right, I think that's about it, and that's really all the time that we have today. Really appreciate it, and hope you have a nice nice rest of your evening, probably on your side, right at this moment. It's early morning for me. You're probably about late evening for you, would be my guess.
Thank you, Reza.
Thank you